aim is to measure power and power factor of a single phase AC RL circuit. So at first I want to tell you some prerequisite theory for that experiment. There are three types of power. First one is active power, which is cos phi, which is a true power that utilized in our AC circuit. Second one is reactive power, which we measured in kVAR. And third one is apparent power, which is a simple multiplication of voltage and current, which we measured in kVA. And we have 3 to 4 types of load. First one is if we have purely resistive load, then the voltage and current are in same phase. If we have purely inductive load, then the phase angle between voltage and current is purely 90 degree. And if we have purely capacitive load, then the phase angle between voltage and current is 90 degree. It means current lead the voltage by 90 degree. And if we have RL load, it means the power factor angle, or we can say the phase angle between voltage and current is in between 0 to 90. And if we have RC load, it means the current leads the voltage and it leads by a phase angle of in between 0 to 90 degree. Setup of that experiment, in which we have one variac, one voltmeter, one wattmeter, ammeter and rheostat, and a coil which is of purely inductive. Now I want to tell you about the circuit diagram. Here we have following instrument which we use in our experiment. This is variac, it means variable voltage supply we can get from that. Now that one is voltmeter, that one is wattmeter, which measured active power, it means it measures VI cos phi. That one is ammeter, through which we measure current. This is resistor, variable resistor, and this one is coil, purely inductive coil. In between the terminals C and 230 we have a inductive coil. This is our circuit diagram. That is our variable voltage supply. Now in the first terminal of our supply goes to the M terminal of our wattmeter, and voltage is directly voltmeter is directly connected in parallel with our supply, which measure the supply voltage. And the second terminal of wattmeter is L terminal, which we connect to the first terminal of ammeter, which is whose range is 0 to 2 ampere and MI type. And second terminal of ammeter goes to our resistor, and resistor second terminal goes to the coil, and coil second terminal goes to our variac. So let's come to the voltmeter. Voltmeter is having a range of 150 volt or 300 volt, but we are using 300 volt range because it required in our experiment, and in this voltmeter is of AC type because we are performing an AC experiment. We are using a AC supply, and it is connected with thin wire, and it's connected in parallel with the supply. Second one is wattmeter, and it is having a voltage range of 250 and 500, but our requirement is 250 volts, so we are taking the 250 terminal, and this is M terminal, L terminal, and it's common, and we are shorting the terminal MC terminal we are shorting because it is required in our experiment. Now that one is ampere meter, it means ammeter, which is having a range of 1 ampere and 2 ampere, and we are using 2 ampere terminal for our experiment, connected in series. Now see the circuit diagram carefully. With the help of that circuit diagram we do our connection. This is our variable voltage supply, through which voltmeter is directly connected in parallel with that supply. You can see that with the help of these two wires we directly connect the voltmeter in parallel with our supply. Now the first terminal of our supply goes to the wattmeter terminal of M. This is, and we are shorting the terminal MC short. Now the L terminal of the wattmeter goes to ampere meter first terminal. Now second terminal of ampere meter goes to our resistance, and the second terminal of resistance goes to our coil, which is connected in between 230 and C. Now the second terminal of our coil goes to variac, And now the remaining one connection of voltmeter, which is of V, is directly connected to the C point of the coil. Here is our observation table. First column is V, it means volt. We have to measure the voltage through voltmeter. Second one is I, it means we have to measure the current with the help of ammeter. Now third one column is for wattmeter reading, and then fourth one is for power. It means we have to multiply the wattmeter readings to its multiplying factor of wattmeter, and lastly we have to calculate the power factor. Now if we see in power column, we have wattmeter reading into multiplying factor. Now question arises, what is multiplying factor? So with the help of this wattmeter which we are using, we have a multiplying factor. So if you see that we have taken a voltage of 250, and now if we see in the bottom of wattmeter, you see that if we are using 2.5 ampere current, then we have to join B1 B2. If we are using 5 ampere, then we have to join B1 E2 or E1 B2. Now we are using 2.5 ampere, it means we have to connect B1 B2. So we have connected, and now we have to see which voltage we are taking. So we are taking 250 voltage range, it means 250 voltage range and 2.5 ampere, it means we have a multiplying factor of 0.5 in that experiment. So we have write multiplying factor 0.5. Now, so let's start the experiment. We have to switch on the supply. Now supply is on. Now we have to vary the voltage. With the help of variac, we are varying the voltage. Now see the voltage rating. So first reading we are taking on a voltage of 220. Now see the wattmeter reading. So in between 100 and 200 we have our cursor. Now it means the one division is of. Now the wattmeter reading, here is some parallax error, but if we see it's 140, approximately 140. So we write here 140 in our observation table. Now come to the ammeter. We are getting a reading of 0.9 in our ammeter. We have to read upper scale because we have connected ammeter to 2 ampere terminal. So we have to read the upper reading, and its reading is 0.9. So we write 0.9 in our observation table. Now we have to multiply wattmeter reading with a multiplying factor which is 0.5. Now if we multiply 140 with 0.5, then we get 70. Now we have to measure the power factor. Now what power factor is? Power factor is a ratio of active power to apparent power. Now what is active power? Active power is Vi cos phi, and apparent power is a combination of current multiplication. So now our active power is P is equal to Vi cos phi. P means active power, Vi cos phi. Now we have to measure the power factor. So power factor is P upon Vi, and then P which we measured through wattmeter, and V we measured through voltmeter, and I we measured through ammeter. Now we have to substitute the value of P, it means active power, which is of wattmeter reading, it means 70. Now we have to substitute the voltmeter reading, which is of 220, and ammeter reading, which is 0.9. Now you have to measure the power factor. So here we get a power factor of 0.35. Now we take another reading of same load. We don't have to vary the load. So here we are getting a power factor 0.35, which is for that RL load which we are using in that experiment. Similarly, we have to take another 2 readings for that same load by varying voltage. Now we are again varying the voltage to a new value. So here we are taking a voltage of 230. Now we get the voltage. Now we are taking the reading for voltage, which is of 230. Now we have to measure wattmeter reading. I think it is at 180. Now ammeter reading, which is 1 ampere. Now with this reading you have to follow the same procedure which I follow for the first reading. Now you have to calculate again the power factor, and now I'm taking another reading. Now this time I'm taking the voltage 240, and now wattmeter reading is 220 because we are having a division of 20. The ampere meter reading is I think 1.6. No, sorry, the reading is I think 1.1. Now this is the reading. You have to calculate the power and power factor for that reading, and you have to take average for power, and you also have to take power factor average for these three readings. Okay, thank you and have a nice day.